Today we're going to be talking about rates of change and slope. And honestly, you guys should remember this from Algebra 1 and Geometry last year. So the rate of change, rate of change is essentially slope. So rate of change is the same thing as slope. And it's the change in y over the change in x. Now the slope of a line is the rate of change of y coordinates to the corresponding x coordinates. So you subtract the y coordinates, subtract the x coordinates. And remember, a very common mistake is to switch those, subtract the x's and subtract the y's. But you do y over x. So a rate of change example. In 2004, 56,878 students applied to UCLA. In 2006, 60,291 students applied. Find the rate of change of the number of students applying for admission from 2004 to 2006, and then explain your meeting. So what you really have there is you really have 2 points. You have the year 2004, and then the number of students that applied. And then we have 2006, and the number of students that applied. So you take your y coordinates and subtract them. And then you take the x coordinates. Since I started with the 60,000, you put 2006 first. Okay, so then you simplify that, which it's okay to give me a decimal in these, since it's an application. So we have 1,706.5. Now our meaning. Okay, so the meaning behind this. The number of students applying to UCLA rose, so you have to tell me that's important. Rose, okay, if it was negative, you'd say decline or went down or something like that. So you need to tell me whether it's rising or not, or declining by 1,706.5 students, and then make sure that you give me units. Students per year. Our next example deals now with a graph. So we have our data showing a fast-growing restaurant chain that's going to be important in our units. In the United States, during the time period of the graph, find the rate of change in the number of stores from 2001 to 2006. So let's get our 2 points for 2001 and 2006. So in 2001, looks like it's a little bit more than 5, so I'm going to put 6. Remember, this is in thousands. And then in 2006, looks like it's really close to 35. I'm going to call it 33. Okay, and realizing that those are estimates, and as long as you're showing me your work and showing me that your estimate is something close, like if you were to put 31 here, that wouldn't make sense. Okay, as long as your estimate makes sense, you'll be okay. So subtract the y coordinates, subtract the x coordinates. I started with 33, so I have to do 2006 minus 2001. We get this answer is 5.4, and this is 1,000 restaurants. Okay, restaurants per year. Now explaining the meeting. We're going to have to write a sentence about that. Okay. The number of restaurants Okay, now I need to figure out whether I rose or declined. We rose by 5.4 thousand. If you want, you could put 5,400 because that's 5.4 thousand restaurants per year. Okay, our next example. And honestly, this one is super basic, okay? Just finding the slope of the line. Think of this as x1, y1, and this is x2, y2. So do y2 minus y1 over x2 minus x1. So I get negative 6 over 2, which is negative 3. Find the slope of the line at the right. Now there's two ways you could do this. One way is getting the coordinates of those points. One of those points is negative 1, 0. The next point would be 1, 1. Subtract the y coordinates. Subtract the x coordinates. 1/2. Now make sure this makes sense. Make sure this is change in y over change in x. So I go up 1 and then to the right 2 to get from my point. So I go up 1, right 2. You could also find the slope of this by actually physically counting it out. So if you made some algebra error here, what you might want to do is just make sure you double check by counting out on the actual graph what the slope of the line is. Now, slope-intercept form of a line. For some reason, our book doesn't really cover finding the slope and intercept of the line and graphing, but this is the most common form that we use. Y equals mx plus b. And this should look super, super, super familiar to you guys. Okay, m is the slope, b is the y-intercept. So notice how this is completely solved for y. Y is standing alone. So you need to solve for y. So I'm going to subtract 4x from both sides. And then I divide by 7. You have to solve for y. So I have negative 4/7 x plus 4. So my y-intercept is the number that's being added, so that's 4. My slope is a negative 4/7. So I go up to my y-intercept. And I want you guys to have 3 points on your line. So if I go down 4 and then right 7, that's 1 point that's on my line. So I went down, which takes care of the negative, and then to the right, which is positive. Now I could also go up 4. Okay, that's my positive piece, but then I have to go left 7 because that's negative. So then I go left 7 and have that point right there. Now I want you guys to use a ruler or some sort of straight edge to connect those 3 points. Okay, and make sure that I can see clearly these points. Okay, so now we graph that line. Okay, there are your 4 lesson questions for the day, and please make sure those are submitted on time. Give me the answers, any answers that might be fractions, as improper fractions, and you're going to have a 4a question, and that's going to ask you for the slope, and you're going to have a 4b, which is going to ask you for the y-intercept. So make sure that you could just put in the numbers for each one of those.